This is SpaceTime Series 24, Episode 45. Coming up on SpaceTime, X-ray blast discovered being emitted by the Crab Pulsar. A new study suggests more than 5,000 tons of space dust are falling on Earth each year. And China launches yet another classified spy satellite. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers studying the Pulsar at the heart of the famous Crab Nebula have discovered blasts of X-rays are being emitted when the Pulsar experiences a sudden glitch known as a giant radio pulse. The findings, reported in the journal Science, mean that these giant radio pulses are releasing far more energy than previously thought. Known as M1, the Crab Nebula is a spectacular supernova remnant, located some 6,500 light-years away in the Perseus arm of the Milky Way in the constellation of Taurus the Bull. The nebula is the colourful debris cloud created by the explosive death of a star between 20 and 30 times the mass of the Sun, whose light was first detected by ancient Chinese astronomers as a new star back in July 1054. At the heart of the Crab Nebula is a pulsar, a rapidly spinning neutron star, the super-dense collapsed stellar corpse of a star that went supernova at the end of its life. Pulsar's whirling magnetic fields power beams of electromagnetic energy in radio waves, visible light, X-rays and gamma rays, which sweep across the sky like a lighthouse beacon. A young neutron star can spin dozens to hundreds of times a second. And if these beams sweep past the Earth, astronomers observe clock-like pulses of emissions and classify the object as a pulsar. The Crab neutron star spins some 30 times every second, and at X-ray and radio wavelengths, it's among the brightest pulsars in the sky. Out of the more than 2,800 pulsars catalogued so far, the Crab pulsar is one of only a few that emit giant radio pulses. These events occur sporadically and can be hundreds to thousands of times brighter than the regular pulses. Now, after decades of observations, astronomers have been able to measure details of its giant radio pulses, including emissions from other parts of the spectrum. The analysis showed the largest amount of simultaneous X-ray and radio data ever collected from a pulsar, thousands of times greater than expected. Astronomers used NASA's Neutron Star Interior Composition Explorer telescope, mounted on the International Space Station, to study the pulsar in X-rays, while ground-based telescopes observed it in radio frequencies. The combined datasets captured activity across some 3.7 million pulsar rotations, and netted some 26,000 giant radio pulses. Turns out these giant pulses erupt really quickly, spiking in a millionth of a second, and occur unpredictably. However, when they do occur, they coincide with the regular clockwork pulsations. The data revealed an X-ray boost of about 4% occurring in sync with each giant radio pulse. And that's remarkably similar to the 3% rise in visible light also associated with the phenomenon. This report from NASA TV.
NASA's NICER X-ray telescope on the International Space Station has just shown that random outbursts from pulsars pack more of a punch than previously thought. Pulsars are rapidly spinning neutron stars, the crushed cores of exploded stars. One of the best-known pulsars lies at the heart of the famous Crab Nebula, located about 6,500 light-years away. Light from the supernova that formed it reached Earth less than 1,000 years ago, in the year 1054. The Crab pulsar spins 30 times a second and steadily blinks in radio, visible light, X-rays, and gamma rays. But it also emits random jumbo bursts called giant radio pulses that can be more than 10 times stronger than its regular signals. Now, thanks to NICER's sensitivity, astronomers have shown that each giant pulse comes with an increase in X-ray brightness as well. Observing the Crab simultaneously with NICER and radio telescopes in Japan, astronomers captured data over some 3.7 million rotations. They show a nearly 4% increase in X-ray emission with each giant pulse. This means the phenomena responsible for giant radio pulses produce 10 or more times the energy previously estimated from radio and visible data alone. Astronomers think all these signals originate from particle interactions in the pulsar's rapidly spinning magnetic field, but the details remain poorly known. Better understanding of giant pulses may help scientists figure out how pulsars like the crab do what they do. It may also provide us with insight into a much more powerful phenomenon called fast radio bursts, which are linked to spinning neutron stars in our galaxy and others much farther away.
This is SpaceTime. Still to come, a new study calculates how much cosmic dust falls on the Earth each year, and China launches yet another classified spy satellite into orbit. All that and more still to come on SpaceTime. A new study has calculated that some 5,200 tons of space dust is falling on the Earth every year. The Earth is constantly encountering dust particles from comets and asteroids. Then there's the zodiacal lights, which we now know is a dust trail left by the planet Mars. All these interplanetary grains of dust usually burn up as they enter the atmosphere, but some are large enough to reach the Earth's surface in the form of micrometeorites. And they've become an important way for astronomers to study the space environment through which the Earth is orbiting. Scientists often collect micrometeorite samples from places as common as roofs and gutters, but those are usually contaminated with pollution and terrestrial dust. The new findings, reported in the journal Earth and Planetary Science Letters, are based on 20 years of pristine micrometeorite particles collected at the Franco-Italian Concordia station located on Antarctica's Dome Sea. These particles are just a few tenths to hundredths of a millimetre across, but getting to them is a mammoth task. To collect and analyse all the micrometeorites they can, 6 expeditions were undertaken to the Concordia station, located 1,100 kilometres inland from the Antarctica coast. Dome Sea is an ideal collection spot due to the low accumulation rate of snow and the near absence of terrestrial dust. The expedition collected enough extraterrestrial dust particles, ranging from 30 to 200 micrometers in size, to measure their annual flux, which corresponds to the mass accreted on Earth per square metre every year. The authors say that if the results are applied to the whole planet, the total annual flux of micrometeorites represents some 5,200 tonnes per year. In other words, every year, the Earth's getting 5,200 tonnes heavier just from dust particles. And that makes these the major source of extraterrestrial matter landing on the Earth, far ahead of larger objects like meteorites, for which the flux is less than 10 tonnes per year. A detailed analysis of these micrometeorites shows that the vast majority, some 80%, come from comets, with the rest from asteroids. By studying these interplanetary dust particles, the authors are getting a better picture of how water and carbonaceous molecules arrived on the early Earth billions of years ago. This is SpaceTime. Still to come, China launches another classified spy satellite into orbit, and later in the science report, a new study has found that Australia's black summer bushfires were so intense they actually caused the stratosphere's temperature to increase. All that and more still to come on SpaceTime. China has launched another classified spy satellite into orbit. The top-secret spacecraft was launched aboard a Long March 4B rocket equipped with 4 strap-on boosters. The mission was flown from the Taiyuan Satellite Launch Center in northern China's Jiangxi province and was placed into a 1,450-kilometre high sun-synchronous orbit. Beijing claims it's an experimental satellite designed to carry out space environment surveys and experiments on related technologies. The 2,800-kilogram spacecraft is the third in the Xi'an 6 series. The other 2 in the series were launched on smaller Long March 2D rockets into lower orbits. The clandestine spacecraft uses a new nanocomposite black coating designed to prevent stray light from disrupting optical cameras. and that allows the spacecraft's cameras to capture better images of faint objects, such as other spacecraft. It means that when Beijing says the satellite's designed to carry out space environment surveys, what they're really saying is that it's a space situational awareness satellite designed to track and monitor, and in some instances, capture satellites belonging to other nations. The ultra-black material it's coated in should absorb some 99.6% of ultraviolet, visible and near-infrared light. The mission marked the 365th launch of a Long March series rocket. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study shows that nearly a third of kids hospitalized with COVID-19 go on to develop a severe form of the disease. The findings, reported in the Journal of the American Medical Association, are based on an analysis of hospital data for some 20,714 US children with COVID-19. Scientists say boys were more likely than girls to develop a severe form of the disease, and children with pre-existing illnesses were also at a far higher risk. Researchers also found that younger kids, those aged between 2 and 11 years, were more likely than older ones to develop a severe form of COVID-19. More than 3 million people have now died from the COVID-19 virus, and another 140 million are infected with the deadly disease since it first emerged in China and then spread around the world. A new study has found that Australia's devastating 2019-2020 Black Summer bushfires produced so much smoke that it increased the temperature of the stratosphere for some 6 months. The findings, reported in the journal Geophysical Research Letters, suggest that black particulate matter from the smoke absorbed heat, leading to an increase in temperature of between 1 and 2 degrees Celsius. Australia's 2019-2020 Black Summer bushfires burnt out an estimated 186,000 square kilometres, killing more than 3 billion terrestrial vertebrate animals, including many highly endangered species, some of whom were driven to extinction. The massive wildfires also destroyed some 5,900 buildings, including 2,779 homes, killing at least 34 people. Smoke from the fires crossed the South Pacific Ocean, affecting not just New Zealand, but also Chile and Argentina. By the height of the fires in January 2020, NASA estimated that some 337 million tonnes of carbon dioxide had been emitted into the atmosphere, pervading the stratosphere and completely encircling the planet. The rapid extinction of giant animals, including wombat-like creatures as big as cars, birds more than 2 metres tall, and lizards over 7 metres long, which once roamed Australia, has long puzzled scientists. Ancient clues about the shape of fossils and archaeological evidence of varying quality scattered around Australia have formed the basis of several hypotheses about the fate of the Aussie megafauna, which vanished around 42,000 years ago from the ancient continent comprising mainland Australia, Tasmania, New Guinea and neighbouring islands. Now, a study by scientists at Flinders University has concluded that it was in fact multiple factors, including the impact of the first human arrivals, as well as things like changes in climate and access to fresh water sources, which all combined to seal the fate of the megafauna. Researchers used sophisticated mathematical modelling to assess how susceptible different species were to extinction, finding it wasn't just the megafauna that was dying out. They found the extinction cascade was likely the result of complex localized scenarios, including the impact of regional climate variations and different pressures from the first Australians as they moved across the regions. A new study has looked at the question of just how many Tyrannosaurus Rexes used to exist, and it's come to the staggering conclusion that more than 2.5 billion Tyrannosaurus Rexes once roamed North America during the Cretaceous period. The findings, reported in the journal Science, suggest that around 20,000 adult T-Rexes probably lived at any one time. The 13-metre-long, 15-ton theropod carnivores reigned as king of the dinosaurs for around 2.5 million years, ending 66 million years ago with the impact of the KT boundary event asteroid into Mexico's Yucatan Peninsula. So, where did they get their 2.5 billion figure from? As part of their calculations, paleontologists used Monte Carlo computer simulations and chose to treat T-Rex as a predator with energy requirements roughly halfway between those of a modern-day lion and Komodo dragon. To date, fewer than 100 T-Rex individuals have been found, and many of those are represented by just a single fossilized bone. How do you tell when someone's trying to make you believe something that isn't true, or trying to get you to doubt something that is true? Tim Mendham from Australian Skeptics says there are actually a variety of strategies that can manipulate you very effectively, but there are also telltale signs to look out for.
There's a whole range of things. I mean, outside of sort of asking them their qualifications, etc., to talk about it, there's a few red flags that can pop up. And this was some research done by people at La Trobe Uni. 5 things to look out for. And these are sort of characteristics of the way their arguments are being put forward. One is the us versus them, and you can put a capital T on them if you like. Sort of they're out to get us, big government, big pharma, big science, big whatever. Anyone who makes up this sort of bit paranoid sort of view is often, for a start, you say, hang on, right, maybe, maybe not. But that's the first flag that pops up. Another one is someone who says, I'm not a scientist, but, and basically when someone says, I'm not a scientist, you should leave it at that, especially when they say, I know what science is all about. That's a flag as well. And then you're starting to realise that qualifications might not be strong. People who then say that the science is not settled, that scientists haven't come to 100% conclusions. Scientists never do. That's not the way science works. Science works by constantly refining, and therefore they're always looking for improvements, but they're rarely going to say it's 100%. Often the alternative practitioners do say we're 100% certain. So as soon as they say that, as opposed to saying the science is not settled, you know that that's another red flag you should be watching out for. Obviously, there's the over-simple explanations. I know Occam's razor says the simple explanation is the best, but in some cases the simple explanation is the most simplistic and can be conspiracy theories down to particular cures. They point out that in this article that science is often messy and it's complicated and it's full of nuances. And so suggesting there's a simple explanation for some of these things in science is straight out weird, especially when they talk about quantum mechanics and that sort of stuff. So they would say they would catch on to something like quantum mechanics and say that's the answer. Well, no, it doesn't work that way. And most of the examples they use are really sort of oversimplified. And then there's, of course, the classic, which is cherry-picking evidence. And you can also cherry-pick quotes. You pull out a bit of a quote, you pull out a few stats, and you use them out of context, and you can make, what do they say, lies, damn lies, and statistics. You can use them to say anything you want, actually, but it's obviously disreputable and dishonest to use things out of context. But it happens a lot anyway. So take a few words here and it sort of can prove your case when the opposite is often true. You often find this with people putting forward references to articles and things. It looks impressive, but when you actually, if you take the time to actually look at some of these references, you realise they often say the opposite of what this person is saying. So they've either just cherry-picked information or just thrown in some random references to make themselves look good. Some of them are just silly-ish. I'm not a scientist, but it's a classic one, so you just say, But these other ones are perhaps some of them a bit more subtle. Cherry-picking is hard to pick in a straight conversation because you have to know what the full context is, and by the time you've done your research, they've probably moved on. So you have to be careful of that one, but if you can work on that one, you know they're cherry-picking, then you've got a good indicator that they're not the full, you can tell that they're not the full
They're
quid.
not kosher.
Yeah, if you see people using these sort of arguments over us versus them, oversimplistic, I'm not a scientist, but science is not settled, things that are unknown to science, but known to me apparently, and simplistic explanations, cherry-picking when you can pick it out, are all good indicators that the person you're talking to is a pseudoscientist and the stuff they're saying is junk science.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.